In Unit 6, we are going to be talking about chemical reactions, how we can write out reactions, balance equations, identify different types of reactions, along with predict the products for various reactions. But before we get into chemical reactions, we need to talk about what is a chemical reaction. Okay, and how does it differ, let's say, from a physical change? So the purpose of video 6.1 is to get you to differentiate between a chemical and a physical change, and also identify changes as being either chemical or physical. A physical change is defined as a change that alters at least one of the physical properties of the substance. When we talk about physical properties, we're talking about things like maybe the shape, the color, something that we could observe with our eyes. Okay? The important thing to recognize about a physical change is that it does not change the chemical composition. At the end of the day, when a compound or when a substance undergoes a physical change, the chemical composition or the formula of that substance would remain intact. Some examples of physical changes include changing the physical state of a substance, okay, taking some liquid water and freezing it into ice, taking that ice and now melting it into liquid water. Anytime we change the physical state, we have not altered the chemical composition. At the end of the day, whether water is in the liquid form, the gaseous form, or in the solid form, it is still water. Another example of a physical change, and maybe a little more tricky one, is the idea of dissolving. If something dissolves in water or in a solution, okay, that is also just a physical change. Okay, salt dissolving in water is still salt. If we alter the shape or size of something, that would be another example of a physical change. Physical changes, I like to think of, are changes in which we could revert back to the original form. If we can undergo, or if we could go back to the original form, chances are we've undergone a physical change. So if we go back to our examples, if I have solid water and I allow it to melt, I could easily get that solid water or ice back by freezing it again. If I were to dissolve some salt in water, I could get that salt back by simply evaporating the water, and the NaCl, or the salt, remains intact. Spectrum, then, we have a chemical change. A chemical change is a change in the chemical composition of a substance. So in this case, we are altering that chemical composition or the chemical formula. Chemical changes occur as chemical reactions. So in the rest of this unit, when we get into balancing equations and writing reactions, predicting products, everything we are doing are examples of these chemical changes. Okay, chemical changes, some everyday examples would be iron rusting. When iron rusts, it forms a completely new compound, iron 3 oxide. Iron 3 oxide is the chemical name for rust, and if I were to look at the formula, it would look like this. Iron by itself is simply Fe. So when iron rusts, it changes the chemical composition of the Fe into the Fe2O3. Another example of a chemical change is the fermentation of grape juice. Grapes that have been fermented undergo a chemical change in their structure, and resulting product is wine. Now, there is obviously a very big difference in the makeup of grape juice versus wine. Chemical changes are those changes in which we can't go back to our original form. Okay, so if we think back, we said a physical change, we could go back. In a chemical change, it's going to be almost impossible or very difficult to go back to our original form. So once iron has rusted, okay, we can't simply get our regular iron back. Wine that has been fermented cannot go back to grape juice. If we think of some more everyday or some other examples, when we burn something, once something has been burned, we cannot revert back to that original form. So again, a physical change is a change in which we can most of the time go back to our original form pretty easily. In a chemical change, we have altered the chemical composition, and therefore we will not be able to revert back. The last thing we're going to are different signs we may observe in a chemical or in a lab that tells us that a chemical reaction has occurred. Okay, the first of those signs is going to be heat. If we mix two substances together and we feel the test tube or the beaker, whatever it may be reacting in, to get hot, okay, and we are producing heat, that is a good indication that a chemical reaction has occurred. Another example is gas being released. Okay, typically when we mix two substances together and we see bubbling, okay, bubbling tells us that a gas is being released. And a release or the generation of a gas is a good indication a chemical reaction has occurred. Okay, many times something as simple as a color change can indicate a chemical reaction has occurred. Now we have to be careful with this one. We could take some food color, dissolve it in water, and that would not be an example of a chemical change. But if we're mixing two chemicals together and get a drastically different color, that is a good sign a chemical reaction or a chemical change has occurred. Okay, the formation of a new substance or a precipitate, and I'm going to abbreviate precipitate, PPT, is a sign a chemical reaction has occurred. Precipitates are those things that do not dissolve in water. So if I were to mix two liquids together and all of a sudden end up with a solid, that would be a sign a chemical reaction has occurred. Okay, our fifth one is going to be a change in mass. If something gains or loses mass, okay, that could indicate that another product has been formed and we have a chemical reaction occurring. And the last one is going to be burning. Okay, when something is burning, we know for a fact a chemical reaction has occurred and we have altered the chemical composition of that substance. So again, physical and chemical changes and signs a chemical reaction have occurred are all of the things you should have understood by the end of this video.